Okay, let's have the solution to example 53 on compound truss. Determine the bar force in all members of the compound truss shown below. So this is the given figure. So AD has a slope of 3 vertical, then 7.5 minus 1.5, half of 3 is also 6. So 6, 6, so therefore AD makes an angle of 45 degrees. Then tangent of theta AB is 12 over 7.5. So theta AB, which is also theta BC, is equal to 57.995 degrees. Then for the angles at D and at E, as DF and EF makes an angle of arctan of 3 over 1.5, and that is 63.45 degrees. So let's begin our analysis by isolating joint D. These are the forces. We will call the force in DF as Q. So summation forces Y equals 0 to downward positive to relate SAD in terms of Q. So SAD sine of 45 plus Q sine of 63.45 degrees equals 0. So SAD is equal to negative 1.265 of Q. Then summation forces X equals 0. So we have SDE plus Q cosine 63.45 equals SAD, which is negative 1.265 Q cosine of 45. So expressing SDE in terms of Q, negative 1.265 Q cosine 45 minus Q cosine 63.456 or 63.45 degrees. So we get Q SDE equals negative 1.342 of Q. Then we proceed to joint E. Summation forces Y first equals 0 to relate SBE in terms of EF. So tangent of theta BE is 6 over 1.5. Half of 3 is 1.5. So theta BE is 75.964 degrees. Then summation forces Y equals 0. These are the forces. SBE sine of 75.964 equals SEF sine of 63.435 degrees. So SBE is equal to 0.9220 of SEF. And summation forces X at E equals 0, leftward positive. So SEF cosine of 63.45 plus SBE, which is 0.9220 SEF cosine of 75.964 plus SDE, which is negative 1.342 of Q equals 0. So we can now express SEF in terms of Q. It is positive 2Q. Then we compute this angle, arctan of 3 over 7.5. So 21.801. We proceed to joint F. At F, summation forces Y equals 0 first. So these are the forces. SEF, which is SEF 2Q sine of 63.45 degrees plus Q sine of 63.45 degrees equals SCF sine of 21.801 degrees plus 80. So 2 sine 63.45 plus sine 63.45 divided by sine 21.801 degrees, that would be 7.225 Q. Then negative 80 divided by sine of 21.801 is negative 215.41. So that's the expression for SCF. Then summation forces X equals 0. So we have SCF quantity 7.225 Q minus 215.41 cosine of 21.821 plus SEF, which is 2Q cosine of 63.45 degrees equals SDF, which is Q cosine of 63.435 degrees. So combining Q 7.225 cosine 21.821 plus 2 cosine 63.435 minus cosine of 63.435, that would be 7.155 Q then equals 215.41 cosine 21.801 to the right. So we can now solve for Q, which is equal to SDF, and it is equal to 27.95. SDF therefore is 27.95 kilonewtons tension. Then for the other members, SAD is equal to negative 1.265 of 27.95. So it is negative, so it is compression. SAD is 35.36 kilonewtons compression. Next is SDE, negative 1.342 of 27.95, so negative, so it is compression. SDE is 37.51 kilonewtons compression. Next is EF, which is equal to 2Q, so 2 times 27.95. SEF is 55.9 kilonewtons tension. Then SBE, which is 0.922 of 55.9, it is positive 51.54 kilonewtons tension, SBE. Then SCF, 7.225 of 27.95 minus 115.41. So it is negative, so it is compression, 13.47 kilonewtons compression. So the remaining members not yet solved are AB, BC, and AC. So we will determine that on the next slide. And we will apply the computed values. So for the continuation, we have here the forces. So we proceed to A, but let's put the reaction components. So remember the angle. So summation forces X, so this is AX 60 to the left, and AY is expected downward, then R sub C upward. So let's solve for AY considering the entire system. Summation moment about C equals 0, counterclockwise positive. So we have AY times 15 plus 80 times 7.5 equals 60 times 12. So solving for AY is equal to 8 kilonewtons downward. So that's why it's downward there. Then at A, summation forces Y equals 0 to solve for SAB. Remember SAB, that's the angle. So these are the forces. And SAD is negative 35.36. Then SAC unknown. So SAB sine of 57.995 plus negative 35.96 sine of 45 equals 8. Equals 8 downward. So SAB can now be computed. It is equal to positive 38.98 kilonewtons. So it is tension. Then summation forces X equals 0. SAC plus negative 35.36 cosine of 45 plus SAB, which is 38.92 cosine of 57.995 degrees equals 60. Equals leftward force. So SAC can now be computed. It is positive 64.38 kilonewtons, so it is tension. Then we proceed to C, but before that, let's solve for R sub C whole system. Summation moment about A equals 0, or you may sum up forces vertical. So therefore, this is 8 plus 80. This is expected 88. So let's just sum up moments about A, counterclockwise positive. So R sub C times 15 equals 60 times 12 plus 80 times 7.5. So R sub C is 88 kilonewtons upward as expected. Then we proceed to joint C, summation forces Y equals 0. Then these are the forces, and remember the angle BC is 57.995 degrees with horizontal. So summation forces Y0, SBC sine of 57.995 degrees plus negative 13.47 sine of 21.821 degrees plus RC, which is 88, equals 0. So therefore SBC is negative. So it is negative, so it is compression 97.87 kilonewtons compression. Then let's check summation versus X if this balances so that we can validate our answers. So if this is almost 0 or 0, then that means our previous answers were correct. So summation forces X leftward, let's check leftward as positive. So we have 64.38 plus negative 13.47 cosine 21.81 plus SBC, which is negative 97.87 cosine of 57.995. So calculating, that's almost zero, so that means okay, so it is balanced horizontally. So there is still remaining joint. All members have been found. So to really validate our answers, let's also check joint B. Although this is not part anymore, but if you want to really check or say that all these answers, these forces are correct, then we must verify that B is in equilibrium. So summation forces X equals 0. These are the forces. So negative 97.87 cosine of 57.995 plus 51.54 cosine of 75.964 degrees. Then minus 38.92 cosine of 57.995. So plus 60, then using the calculator, it is almost zero, so that's okay. So finally, summation forces Y, downward positive. So let's check if it is also zero. So negative 97.87 sine of 57.995 plus 51.54 sine of 75.964 plus 38.92 sine of 57.995. So if this almost zero, then that validates our answer. So it is almost zero, therefore all these answers are correct. So there is another way, another method. I hope that you also experience this, but it needs your skills in math, analytic geometry. So I'll present it on the next slide. Another solution, you might like this solution. And let's only check the forces in members AD, CF, and BE. So negative 35.36, 51.34, and negative 13.47. Then after we know these forces, then the procedure for determining the other members will be the same. So for this method, this is the figure. Let's cut this three members here with a circular section so that three unknown members will be involved. And the 80 kilonewton force is also involved. It is inside this section. So let's find the intersection of any two unknown forces here. So let's extend the line of action of BE. It intersects with CF. I'll call this point C. Then let's extend the line of action of AD. It intersects with BE. So let's call that point B. And finally, extend CF and AD, their intersection. Let's call that point A. So if we sum up moment about these points here, we can solve for example, summation moment about A, we can solve SBE. Summation moment about B, we can solve SCF. And summation moment about C, then we can solve SAD. So remember. So first, let's find the point of intersection A. That's the point of intersection between AD and CF. So because these are straight lines, we can easily determine the equation of straight line. Since this is 45 degrees, if A is the origin, then the slope of AD is 45, which is 1. 45 degrees, tangent of 45 is 1, and that is represented by x equals y or x minus y equals 0, the equation of AD. While for CF, C is at 15, 0, while F is at 7.5, 3. So by 2-point form, y minus 0 over x minus 15 equals 3 minus 0 over 7.5 minus 15. So simplifying, y equals negative 2/5 of x minus 15. But because the equation of AD is x equals y or y equals x, we replace y by x. So x is negative 2/5 of x minus 15. From here, we can solve for x. 30 divided by 5 plus 2, so 7. 30 over 7. X is 30 over 7 meters, and y is also 30 over 7 because x is y. So therefore, point A is at 30 over 7 from A meters, then 30 over 7 above A. So that is A. So having found located A, which is the intersection between AB and CF, we can solve SBE. So summation of moment about A equals 0, counterclockwise positive, the horizontal component is counterclockwise, the vertical component of SBE is also counterclockwise, and the moment of the 80 kilonewton load is clockwise. So first, horizontal component SBE, cosine of 75.964. The moment arm is 6 meters minus 30 over 7 because this is 30 over 7. So the vertical distance between SBE cosine 75.964 and A is 6 meters minus 30 over 7. Plus SBE sine of 75.964, then the moment arm is 9 minus 30 over 7. Why 9? Because E is 9. 9 meters from A. 7.5 plus 1.5, 9. Then distance of A horizontally from support A or origin A is 30 over 7. So I hope you got that. Then equals 80 times, of course, 7.5 minus 30 over 7. So 80 times 7.5 minus 30 over 7. So from there, we can now solve SBE. SBE is equal to 51.54 kilonewtons, which is the same answer in our previous solution. Then let's find the location of the intersection between AD, this is the equation, and BE. So equation of BE. Point B is at 7.5 comma 12, while point E is at 9, 7.5 plus 1.5, so 9 comma 6. So by 2-point form again, y minus 6 over x minus 9 equals 12 minus 6 over 7.5 minus 9. So simplifying, y minus 6 equals negative 4 times x minus 9. Since y is x again from the equation of line AD, so replace that by x, minus 6 equals negative 4x minus 9. Negative 4 times negative 9 is 36, plus 6, 42. Then 42 divided by x plus 4x, 42 divided by 5 is 8.4. So B is at 8.4 comma 8.4 because y is also 8.4 meters. So having located B, we can now compute the force of SCF. So summation of moment about B equals 0, counterclockwise positive. The horizontal component of SCF is SCF cosine 21.801, and the moment arm is equal to 8.4 minus 3. 8.4 above AC, then minus 3 because F is at 3 meters above. So SCF cosine of 21.801 degrees times 8.4 minus 3. The vertical component is downward, so it is also counterclockwise. SCF sine of 21.804. The moment arm is 8.4 minus 7.5 because that's 7.5 and that is 8.4. Then plus 80 times the same moment arm, quantity 8.4 times minus 7.5 equals 0. So from there, we can now solve SCF, and it is equal to negative 13.46 kilonewtons. Our answer before was negative 13.47, so there's a little discrepancy, but that's the same. So SCF is 13.46 kilonewtons compression. And finally, let's locate C. We already found the equation of BE. We only need equation of CF, where C is at 15 comma 0 and F is at 7.5 gamma 3. So this is the equation of CF. Where is CF? CF is is here. So y equals negative 2/5 of quantity x minus 15. If we simplify this, negative 2x to the left, so 2x plus 5y, then equals negative 2 times negative 15 equals 30. So that's the equation of CF. For BE, on the other hand, BE, this is BE. So negative 4x to the left, so 4x plus y. Then negative 4 times negative 9 is 36 plus 6, 42. So that's why we have 4x plus y equals 42, equation of B. Solving these two equations simultaneously will give us the location of point C, which is at 10, 2. So you just solve these two equations simultaneously. You will find that C is at 10, 2 meters. So therefore, we can now solve SAD, summation moment about C equals 0, counterclockwise positive. The horizontal component is SAD cosine 45, and the moment arm is 6 minus 2, because y is 2. So 4 meters. So SAD cosine of 45 times 6 minus 2. The vertical component is also counterclockwise. SAD sine 45, the moment arm is 10, from A 10, minus 6, 10 minus 6, because D is 6 meters from A. So SAD sine of 45 degrees times quantity 10 minus 6, then plus 80 times 10 minus 7.5. So 80 times 10 minus 7.5 equals 0. So solving for SAD is negative. SAD is negative 35.36, which is the same answer in the preceding slides. So SAD is 35.36 kilonewtons compression. So as I said, for the rest of the members, once these three are known, then you can apply method of joints at each joint. You can solve for the rest of the members. So that's it for this problem. I hope that you experience this in your college life, or if not, then this is your experience.